the goal right now. All right. So we are going to look at number 16, but I want to kind of come over here and refresh our approach on this. David, this was it's been posted in Google Classroom for a few days now. Okay. We'll get there. Okay. Oh, the maximum error amount. Don't worry about it. We're going to skip that one. Throw it out. Okay. If I have time, I'll do it with you, Gabby. Okay. You just do the next one beyond. So I think they wanted 5. You just have to find the value of the 6th one. Okay, so let's look at this chart. We are going to kind of follow this pattern for our conditionals and absolutes, okay? So I'm going to try to find, and typically it's a comparison series on a lot of the ones that are here. I'm going to try to figure out if the series just converges or diverges, okay? And then if it converges, I am going to do basically an alternating series test on it, because that's the one where we can get an absolute value of something. Ratio sometimes works, but on these ones it doesn't, okay? So we're probably do an alternating series test to see if it converges again. If it converges again, then it's absolute. If it doesn't converge, if it diverges, then it's conditional, okay? So I am going to look at this first one here. And we're going to do a comparison series on it. So we're going to do a limit comparison test. Okay, so I'm going to use limit first. And I need to have something to compare it to. So what do you guys think we should compare it to? There's actually 2 things that would work on this. Lorenzo has it in the chat already. Does everybody else want to do 1 over n? I'm frozen in a really bad position on one of my things. Okay, so Gabby said she did 1 over n. Natalie did 1 over n. Perfect. Okay, so limit comparison. We're going to compare to 1 over n. Okay, so we're going to do that, and so we're going to do the limit as n approaches infinity. And when we do limit comparison, it's technically absolute value, so the negative 1's going to drop out. So we just do n plus 1 over n squared times, and then I flip the reciprocal because I'm really dividing. So what happens is the limit as n approaches infinity, it would be n squared plus n. The absolute value I'm just going to drop over n squared. So what's my limit equal to? Oh, I wrote it down. I ruined the question. My limit is equal to 1. Okay. Okay, so you all can see the weird post. Well, that's great, isn't it? It's too bad we couldn't put that on the t-shirt. Okay. Yeah, it's really funny. I'm really glad you all don't take I don't know, maybe you do take screenshots of me in weird positions and put them up on the internet. Okay. It doesn't matter which one you do. Okay. You could have probably done that one too, Gabby. All right. I happen to choose limit. All right. I'm going to try to find my chart, right? Where's my chart? Not that, not that. Is it this one? No. Didn't go. Oh, I might have put it away. Oh, maybe it's this one. No. I've been really concerned about the schedule today, apparently. All right. Orange sheet. There it is. Okay, so limit comparison test says if I get a limit and it's greater than 0, they either both converge or both diverge. Okay. All right, so I am greater than 0. Oh, we forgot to tell if it converged or diverged. So what about 1 over n? Does it converge or diverge? Ah, okay. It's the p series with p equal to 1 or the harmonic series, it diverges, right? So that means that this one also diverges. So we just found by limit comparison test. Limit comparison test. Okay. So we found that that it diverges by the limit comparison test. But I want to check the absolute value of it too to see what happens. Okay. Because it's possible that it has conditional convergence, which that's what doesn't make sense to me. We got it to diverge. Okay, let's look at the alternating series because I'm looking at the answer key I got this from, and they're saying it's conditionally convergent. So we're doing the absolute value one. So that's going to be alternating series test is what we're going to do next. AST. Series test. All right, so alternating series test, I need to find the limit as n approaches infinity, and it's the absolute value of the function, so I'm looking for this. So on this one, is the numerator going to grow faster or the denominator going to go faster? You got that it diverged, Gabby? That's good. Okay, so the denominator, I'm sorry, I'm going too fast. I'm not letting everybody answer. Oh, that it's conditional? Okay, good. Then I'm doing it the right way, hopefully. All right, so the denominator, it grows bigger, which means that my limit is going to 0. I could have also done L'Hopital. Okay, so that one, that's checked off. I need to now see if the terms are decreasing, right? So we're going to have put a 1 in. I would get 1 over, sorry, I would get 2 over 1. I put a 2 in. I get 2 over 2 squared is 4, which is 1/2. I put a 3 in. I get 4 over 4 squared. I'm sorry, 3 squared, right? This was 3 is 9. Okay, it looks like it's getting less. Okay, so I know that it's decreasing. So I know that it just passed the alternating series test, so it converges by alternating series test. So that means the absolute value of it converges. So therefore, it converges conditionally. Okay. All right, I'm going to give you guys a second there. All right. Okay, let's look at 17. So 17, if I think about what goes on with pi, okay, pi, or cosine of pi is -1, right? So cosine of pi is -1. And then if I were to put a 2 into this, I would get +1. And then if I were to put a 3 in, I would get -1. And then if I were to put a 4 in, I would get +1. So isn't this one alternating? Are you trying to tell me that it's alternating, Gabby? Okay. I hope that's what you're saying. So this is really the same thing as saying n equals 1 to infinity of -1 to the n over n. Okay. So I really guess I don't even need a comparison test. That's really just a p-series, right? So does this p, it's really just 1 over n, isn't it? So does that's a p-series, does that converge or diverge? Is it bounded and monotonic? Yes. Remember, the whole series has to be bounded and monotonic, not just the numerator. Okay, it's not the numerator is not monotonic, but when you add the denominator, it is. Okay. All right, it's a p-series that diverges. Okay, this one is making sure I am looking at the right one. Yeah. All right. Oh, it's over here. Diverges. Okay. So I've got it diverging. I also want to do alternating series test on it to see if I can get conditional convergence on it. So I'm going to do the alternating series test. So basically, it's the absolute value of it. So I'm going to look for the limit as n approaches infinity of 1 over n. What's that limit equal to, everybody? Did you cut out a star and put it on your head, Natalie? That looks like Ellie's like Spirit Day outfit, only it's Pikachu's today. She's got Pikachu's taped to her shirt. Because she's in middle school and that's still cute, I guess. Okay. Then I got to look and see if my terms are decreasing. So I put in a 1, I get a 1. I put in a 2, I get a 2. I put in a 3, I get a 3. I put in a 4, and so on. So we definitely have the two conditions met. So it converges by the alternating series test. Therefore, it is conditionally convergent. All right, I'm going to give you a minute there. Make sure you've got it. Okay, I am going to, let's look at number 18. Okay. So number 18, I would have to do a comparison series, right? In order to, so I'm going to have to compare it to. So what do you guys think we should do? Yes, Lorenzo, use the ratio test otherwise. Okay. That would be our second choice. Okay. So you guys some of you are already typing the comparison in there. Tell me what comparison I want to hear from everybody. What are we going to compare to? All right. All right. So compare to 1 over n squared. Okay, because n squared is a p series. P is equal to 2, which is greater than 1. So does that converge or diverge? Does the p series converge or diverge? All right, so this one converges. Oh, that's new and different, right? We haven't had that happen yet. So it converges by p series. All right, so now I am going to do the alternating series test again because I have an alternating series. So alternating series test. The first thing I'm going to do is the limit as n approaches infinity of 1 over n plus 1 squared. What's my limit equal to? All right, good job. It is equal to 0. Okay. And then I have to check to make sure my terms are decreasing, right? So I'm going to plug in. So I get 1 over, let's see, 1 plus 1 is 2, squared is 4. 2 plus 1 is 3, squared is 9. 3 plus 1 is 4, squared would be 16. It's definitely decreasing. So it converges by alternating series. So therefore it converges absolutely. Okay. How we doing? We're still doing good on time. I'm going to get through the ones I want to. We might even be able to go back and do number 13 for Gabby because I know she wanted to do that one. Because I skipped it the other day. All right, it'll save me time that I won't have to video it later, right? Okay, let's look at number 19. Okay, I'm going to have to do a comparison on 19 as well. Okay, I'm kind of curious. I know some of you probably got it. What are we going to compare to? Lorenzo's too quick. What are we going to compare to? Lorenzo put his idea in the chat. Oh, we got stuck. Okay, so let's talk about the comparison piece. All right, let's play with this a little bit. As we approach infinity, that 2 is not going to matter, right? Okay, so if I'm approaching infinity, the 2 is not going to matter, which means I really have n to the 1/2 over n. And this is me just trying to set up the comparison part. So which means that if I were to like subtract those, right, or cancel one into the other, I would have 1 over n to the 1/2. Or n to the negative 1/2, right? Because I'd have 2 halves minus 1/2. All right, are we good with that now? Okay, so we're going to compare to 1 over n to the 1/2 power. What kind of series is 1 over n to the 1/2? I want to hear from everybody. What kind of series is that? That looks terrible. I'll fix it. Okay, so it is a p series where p is equal to 1/2, which is less than 1. So does it converge or diverge? All right. I'm waiting because I want to make sure everybody has a chance. All right, so this part diverges. And then we're going to do our alternating series test, okay, to see if we can get it to converge by that. And if it doesn't, it will be conditionally convergent. So step 1, find the limit as n approaches infinity of the square root of n over n plus 2. All right, which one's going to grow faster, the numerator or the denominator? So which one grows faster, the numerator or the denominator? All right, the denominator, nice. It's okay, spelling doesn't count, remember? All right, so that means that that's going to be 0 if the denominator grows faster, right? All right, the second thing that we need to look at is the decreasing terms. So I'm going to do this a little differently. I'm going to put n equals 1, n equals 4, n equals 9n, okay? Because those are nice square numbers, right? And they're still decreasing, hopefully, over those. So that would give me 1 over 3. This would give me square root of 4 is 2 over, let's see, 6, which is 1/3. So we're not decreasing yet. Okay, it's still kind of staying the same. All right, this one here would be 3 over 2 plus 9 is 11. I'm going to go one more, 16. See if I can get some. I think that this was 0.27 when I calculated it. 16 would be, square root of 16 is 4 over 16 plus 2 is 18, which when I looked in my calculator was 0.22. Okay, I actually did this one ahead of time. Can you believe it? All right, so therefore it's decreasing. So we know that this one converges by alternating series test. So overall, we are conditionally convergent. Okay. Again, when you take the test, you need to show me your thinking on the paper. Okay. You can't just click converges, diverges, converges absolutely, converges conditionally. Okay. Because in this respect, it's a little bit more multiple choicey, right? And there's a 50-50 shot on a lot of this stuff. Okay, let me skip. I'm going to skip over 20 and make sure we get 21 in. And then I'll go back and do 20. Okay, Gabby? So, okay. All right. I know that you need to know. Okay, we'll put it back. We'll put it back in just for you, Gabby. Okay. All right, so I'm going to adjust 21 just a tad. Okay. I want to, let me find my notes on this really quick. Those aren't even the ones I want. Where's my, I think it was this one, maybe. I was in the right spot to begin with. There it is. Okay. So this is more similar to the second example in the notes. Okay, or well, it's the third example in the notes. Okay. On the test, I want you to make sure you can do this second example. So make sure you go back and look at example 2 in the notes. All right, hope that you were supposed to watch on yesterday. Okay, so make sure you can do example 2. I'm going to probably make it more similar to that because this is a little bit too much guessy and checky for me. Okay. I'm looking at Lorenzo. So could we determine absolute convergence with any test? Correct, Lorenzo. You can use the root or the ratio as well. That's fine. Any of them with the absolute value. A lot of times, especially like I tried the ratio on the first one and it came out inconclusive. So that's why, so you gotta, it's kind of a guess, right? And if one of them comes out inconclusive, you got to pick a different one and see if you can get it to work. Okay? Because inconclusive doesn't mean you're done, right? It means that you have to try something else. Okay, so we are going to approximate this sum, so the error is going to be less than this. I'm not worried about this piece, so you can cross that question out, okay? All right, so I'm gonna try to set this up the way we did in the notes. So we have the sum minus S sub n, that was the little formula they were using. We know that that's less than or equal to the remainder, okay? Which we know is less than or equal to the next term, or the first skipped term. We want that value to be less than 0.001. Okay, so my next skip term means, hey, plug n plus 1 into that guy and do absolute value of it, right? So I'm ignoring the numerator. So my numerator would be 1 over 2n plus 1 factorial. I think I did this, I feel like I did it wrong during second period. At least that part of it. Okay, then I want that less than or equal to, and what's another name for 1.001? Oh, yes, it would. Thank you. That's where I'm like, I did something different. Thank you, Gabby. All right, let's see what we got. Okay, I'm seeing a lot of 1 over 1,000s. Excellent. So 1 over 1,000. And then here's where we go back to when I was looking at these. I'm like, how did they get these inequalities to work out? You got to go back to like the elementary school like version or middle school version of cross multiplication, right? I want to get this guy to the other side, so I'm going to multiply by 2n plus 1 factorial on both sides. So that gives me, and I'm going to go here, 1 less than or equal to, did I write that the right way? Yeah, I think I did. 2 times n plus 1 factorial over 1,000. And then I gotta get the 1,000 back to the other side so I can isolate the n. So I'm gonna multiply both sides by 1,000. So I get 1,000 less than or equal to 2 times n plus 1 factorial. Personally, I like looking at it the other way. So I know whatever I put in here has to be bigger than 1,000. Okay, so I'm gonna start testing n values. And I'm literally guessing and checking this. The other version of it is that you can solve it. The only reason I'm guessing and checking is because of the factorial. I can't undo a factorial, okay? But it's not too horrible to guess and check this one, all right? So I'm gonna start with n equal to, it's not probably gonna be 1. Let's pick something bigger. Let's pick something like 3. Let's see what happens with 3. So we've got 2 times 3. Oh, I think I totally did it wrong. Maybe not, I don't know. 3 factorial, I might be wrong on that one. It'd be 4 factorial, wouldn't it? Okay, so if I put 3 in, I get 3 plus 1 is 4 factorial. 4 factorial is that 24? Is that right? So I would only get 48. Okay, good. Thank you, David, for verifying for me. Okay. I am getting out my calculator. I don't know, do I have a factorial on this? No. All right, let's try and let's go bigger. Let's try n equal to like 6 and see what happens. So 2 times 6 plus 1 is 7 factorial. So what's 7 factorial? Does anybody have their calculator going? Let's see if I have a Desmos going. 7 factorial. Does it do that for me? It didn't. Oh, there we go. That's what I want. Did it put it in? No. 7 factorial. Okay, so I got 50, 40. So think about what I have to do there. That gave me 50, 40 times 2. Times 2. 1080. that wasn't 1080, was it? It was 1080. I forgot a 0. Okay, 1080. That looks terrible. I don't like it when I write on it up like this. 1080 or 180. Yes, you can use a calculator. See this button? See this thing right here where it says calculator? That means you should use your calculator. Okay. All right. So we got to pick something in between there, right? So let's try n equal to like 4 and see what happens with that one. So if I do n equal to 4, I get 2 times 5 factorial. So let's try that in the calculator. Andy, stop popping that outside my door. 240. Okay. You're doing it mentally. All right, well, I don't think we're quite there yet. I picked wrong. Let's try n equal to 5. So it'd be 2 times 6 factorial. We want to be great, just greater. What's the lowest n that's going to get us greater than 1,000? So let's try 6 and see what happens. Or 6 factorial. So there we go. We're finally greater than 1,000 because I got the, I don't even remember. What was it? 1440. 1440. So I know that the n has to be equal to 5 on this one.
Miss Ballard?
Yep, go ahead, Gabby.
So how come when we're like solving the equation, we use greater than or equal to, but then when you do the answer, you put equals?
Because that is the first n value that we would have to be equal to get greater than 1,000 as our answer.
Oh, okay. And then also, so in the notes, wait, hold on, give me a second.
Okay. Anybody else got any questions, comments, or concerns?
Can you scroll up a bit?
Yep.
So I want to see the 1,000 part again. So for the yellow, the 2n with the, where did the 1,000 come from? That was under the 2n part.
When we are able to rewrite that, if you go back to elementary school, that's one as 1/1000th. So I just converted the decimal into a fraction.
Oh, okay.
Okay. You could justify by writing a sentence. I'm just getting, I think you've got enough work there to justify it. Okay. All right. I'm going to go to Lorenzo's question. Why would we want to find the error bounds of a series? Because it tells you to. If you, whatchamacallit, it's possible because you want to know how good or how good of an estimate something is, right? That's why we want to find the error, right? This isn't the only thing we're going to find error in. This is the first one, okay? In the second half of Unit 10, we have error again. Gabby, go ahead.
Okay, so on example 2 in the notes, it says determine the number of terms required, but that doesn't say that in this question. So why do we do it the same way? Because it's it's part B that says like how many terms are needed. So wouldn't we do part B that way?
How many terms are needed? Maybe I just didn't. I ignored the question and did it like we did in the notes because that's what I'm going to test you. How I'm going to test you.
Oh, okay. So
okay.
If we were doing it,
I answered B. I crossed out B, and what I did was answer B. I didn't care about A.
Okay. So
okay.
Are they going to ask us that, like, so that the error will be less than 1/1000th?
Yes.
So how would we solve it that way?
That we're going to add that the error will be less than 1/1000th. That is what we did.
Well, I thought we did how many terms are needed.
How many terms are needed? We determined the number. Yes. So approximate. So the error will be less than 1/1000th. Okay. So if the error is going to be less than what? So that's the same question basically that we're asking on 20. Okay. So that's where you have to go. You have to look at the next missing term, the value of the next missing term. Okay. So if they approximate the sum of the series so that the error will be less than 1/1000th. So what did they do? They added up the terms. Okay. So to do this one, and this isn't something that we learned in our notes because I pulled the review from something different than I pulled our notes from. Okay. So I'm going to ask it, the question I'm going to ask on the test is determine the number of terms. Okay. So I'm going to ask this question on the test. Okay.
Okay. And
All
we'll
right.
solve it before we did it, right?
You still want me to do A?
No, I mean, are they gonna put that on the AP test?
It's possible. When we get more into review, we'll see if that pattern comes up and we can address it then.
Okay.
Okay. And remember, when we're talking about this question, okay, we're talking about either like one part of a free response or maybe one multiple choice. You're probably not going to see it more than one time. Okay. So we got to pick up some of these ones that we can see more than one time, but we're going to try to go for our biggest bang for our buck, making sure we can do rate problems, making sure we can do volume and area problems, making sure we can do some of those other things where we get a lot of bang for our buck. Okay. The what should we call it? The baby bird, right? The separation of variables, you know, that's going to be there. All right. All right. I'm going to do the joke, and then anybody who wants to hang around to watch number 20 or number 13 or any others, I will stick around a little bit into lunch. Okay. Does anybody feel like we need time after school, or are we going to be good? For the actual AP exam or for our test this week? We're good after school, Lorenzo says. The AP exam, the district met this morning with all of the admins from the high schools, and they're making that decision. I have yet to hear what the outcome of the meeting was. Okay. Most of us, most people that I have talked to, both on our campus and off campus, really wanted the second date, which was May 24. So that's what we're keeping our fingers crossed for right now. Okay. So that way I can probably be done with curriculum no later than the last week of April, hopefully, and we can get reviewing the first week of last week of April, first couple weeks of May. Okay. Yes, College Board does now have 3 different days, and our district wants us to the entire district give it on the same day. Nobody, even in the Facebook group online, nobody is ready. Hardly any people are ready for the first set of dates. Okay. So we nationally are not in the same. We are all in the same boat. Okay, so thank College Board for letting it be a little later this year. All right. So we will let you know when I find that out. Okay, and then we will be able. That will give us a little bit better plan. All right. Obviously, we're not taking a final, right? Because it's going to be, if it's the 24th of May, we're not doing finals. Okay. We're not doing the June dates are probably not going to be a possibility for us. Okay, unless there's like some reason where you really need to. Okay. So, okay. So let me start again. So we've got the approximation of the sum of series by first 5 terms. We're just going to basically plug our ends in there and then throw it into our calculator, right? So I guess I could do it by hand too. They have both answers. So -1 to the first would be -1 times 2 would be -2 over 1 factorial, which would just be -2. Plus my n squared, this 2 would be +1 times 2 is 2 over 2 factorial, which would just be 2, so that would be 1. Then I'm going to put in a 3. 3 is going to make it -2. 3 factorial, I believe, is 6, so that's -1/3. Okay. And then we're going to do, I put the 4 in there. That's going to be plus, it would be +2, 4 factorial, 24. Why did I put the factorial after the 6? I don't know. All right. And so that would be +1/12. All right, we got to go first 5, so I've only got 1 more left. The odd's going to make it -2. 5 factorial, I believe, is 120, so it'd be -1 over 60. I'm looking at the answer key. Yeah, it is. Okay. If I was to take and add all that up and I did all the common denominators and everything, it would be -19 over 15 is what it would reduce to, or it would be -1.2666. Okay, but that's not the answer we want, right? That was approximate the sum. That was the first sentence. Is that what you got? Okay, we haven't found the maximum amount of error part yet. Okay, so the max error, let me go to a totally different cover we haven't used. So max error is the value of the first skipped term, right? The last unused term. So it basically says that we would do, so we would, the remainder is the absolute value of the term beyond it, or less than the term beyond it. Okay, so the next term would have been 6, right? So it would have been 6 would have been even. So that would be 2 over 6 factorial, whatever 6 factorial is, okay? And then when they put that in their calculator, they got that the remainder, or the, is 0.00277. So basically you find the value of the term beyond. Okay? Is that good? Makes sense? And it won't be the first time. There's another place where we apply that concept of going the next term beyond. Okay, good. All right, are we done, or do you want me to go do 13 for you, Gabby? Because I know you were wondering about that one the other day. Yeah, okay. I still haven't gone back and figured out 10 yet, so I'll do that here in a little bit and I'll video it and put it up. But let's go do 13, okay? Because 13 isn't too terrible. All right, so I've got to do the integral test on it, right? Which means I have to do the integral from 1 to infinity of n plus 2 over n plus 1. Okay, or actually not n, we're going to use x, right? We're going to switch into x's and then throw a dx after it. That's just the way, the proper notation to use. All right, do you remember how to integrate that? What do we have to do to integrate it? This is one of those problems that I wish we were all in my classroom. It's not quotient rule. Quotient rule is derivative, not integral. All right, we get to use some long division. Usually I get groans when I say that. So it's n plus 2 and n plus 1. Okay. All right, so basically this goes in there one time, right? And then 1 times n is n, and 1 times 1 is 1. Swap your signs. You get that it's 1 is the remainder, so plus 1 over n plus 1. So this is equivalent to 1 to infinity, 1 plus 1 over x plus 1 dx. I don't know why I switched it back to n's and x's. Just, you can use just the x's, it's fine. All right, so now we do the limit as b approaches infinity from 1 to b of the 1 plus 1 over x plus 1 dx. I'm going to move my work this direction here in a second, so I'm going to give you a minute to write. Okay, so when I integrate, I get the limit as b approaches infinity of, let's see, I integrate the x1, I get an x plus natural log absolute value of x plus 1 from 1 to b. And then we're plugging in our b, so the limit as b approaches infinity of b plus natural log of b plus 1 minus 1 plus the natural log absolute value of 2, which is just going to be natural log of 2. Okay. All right, then I plop the infinity into there, so I get infinity plus natural log of infinity minus whatever this mass is. And that's huge, so it's going to be infinity. So if it's equal to infinity, does it converge or diverge? Long division isn't that gross. It doesn't converge, it diverges. right? If it equals infinity when we do the improper integral, it diverges. Okay? That's not, it isn't on the chart, you're right. I'm sorry, do I need to add it to the chart?